In example 2, we're interested in the times when a particle or an object is stopped or has no acceleration. We'll also want to know when the object is speeding up or slowing down. And so we're going to use the table on the next slide to record possibilities for all of these. So they remind us that an object's velocity is going to be either positive, moving to the right or moving up, negative, moving to the left or moving down, or zero, meaning that it is not moving. And also an object's acceleration is either positive, negative, or zero. So let's take a look at the table. Now, if my velocity is positive and the acceleration is positive, that means that my particle is going to be speeding up. And again, an easy way to remember that is that the signs are the same. They're both positive. In fact, it might help to jot that down. All right. If the velocity is positive and the acceleration is negative, I have opposite signs, and it will be slowing down. Now, if the acceleration is 0 and my velocity is positive, that means that I have a constant velocity. It is unchanging, but since the velocity is positive, it will be moving to the right or up. Okay, now what about a negative velocity? So negative velocity, positive acceleration, opposite signs means that it is slowing down. Here I have a negative velocity and a negative acceleration, meaning it's getting less negative, less and less negative. That's the same as speeding up, strictly speaking. And a constant velocity, again, is as a result of my 0 acceleration. But in this case, since the velocity is negative, we will be moving left or down. Now with a 0 velocity and a positive acceleration, the 0 velocity means that the particle is stopped, but there is a rightward acceleration that is acting on the particle, even though at the moment it is stopped. So, okay, how do we understand something like this? How is it possible for a particle to be stopped and yet have a rightward acceleration being applied to it? So this is like a baseball that you've thrown up into the air. When it reaches the top of the arc, the velocity is equal to 0. It's neither moving up nor moving down at that particular time. So at that instantaneous velocity is 0. However, the acceleration due to gravity doesn't cease to exist. It continues to act on the ball, and that is actually what causes the velocity to then change from positive to negative. And so what we have is a turning point in our graph. We'll talk more about that in the next lesson. But let's take a look at this situation here. Velocity is 0, meaning the particle is stopped. And a negative acceleration means that the acceleration is acting in the left direction. And finally, if the velocity and acceleration are both equal to 0, the particle is stopped and there is no acceleration.